Hello and welcome to part 2 in our short series on modeling the Lego block. In part 1 we had modeled the basic geometry of the block, and we had also set up some global variables or XYZ variables here, and we had dimensioned the block based on multiples of those global variables. We'd also created the basic geometry of the stud and the embossed text on top of that. So in this part 2 what I'm going to do is continue on where we left off. I'm going to take the model of the single stud plus text, and I'm going to create a linear pattern feature to create multiple copies of that, and I'm going to do that based off these global variables again. So what I want to do is create multiple copies of both of these features at the same time. So what I can do is I can either select them here from the feature tree, or I can do it within the pattern feature, but I find this is the quickest way is to highlight both of these. So selecting one and then control click on the other one. So with those two selected, I'm going to go to the feature tab, create a linear pattern feature. So this would be something like an array that you may be familiar with from other packages. So what I want to do now is I will specify two directions. So one direction corresponding to my global X variable, and another corresponding to my Y variable. So let's take the X direction first. So in this selection box here, I'm going to highlight some feature that's running in my X direction. So for example, I can pick an edge here, so I can have this being patterned in my X direction. That's one way to do it, is using an edge. Another way might be to have it running perpendicular to a plane. So let's say if I select the right plane here, that feature would be patterned along an axis that's perpendicular to the right plane, for example. Probably the simplest thing, if you have an edge running in the correct direction already, would be to just use that edge. Now you may notice that the direction of that may vary, so you can reverse the direction with this icon here with the two arrows. Toggle that, or you can also toggle using this little grey arrow down here. Oops. Okay, so that's the direction. The spacing then will be 8 millimeters. It's on there. Yeah, so direction 1 here is going to be my X direction. Direction 2 here will be the Y. So the spacing will be 8 millimeters, corresponding to the spacing of the Lego units that we spoke about in the previous video. For the instances here though, rather than putting in a value of 2, for example, what I want to do is base this off of our global variables that we set up previously. So if I come along and modify this variable later, I want to also increase or modify the number of studs in this pattern. So rather than putting in a value there, what I'm going to do is create an equation. So I'll start with equals, come down to my global variables, and I'm going to set this one equal to the global X variable. And if I click OK on that, you'll see that is calculated as 2, which is the same as my initial value for the global X variable 2. And you can toggle over and back between your equation view and your variable view like that. So that's fine for the X direction. Down here then in direction 2, I'm going to set this equal to my Y direction up here. Now you can see that's gone in the that's gone in the wrong direction here, so I'm going to swap that around. I'm going to set my spacing again to 8 millimeters, and I'm going to change the number of instances here from 4, and I'm going to let that equal to my global variable Y. Okay, and that should be that for that pattern feature. Now the advantage of using the variables there is that if I come along later, go to manage equations, and let's say I change that value to 4 in the X direction and let's say 6 in the Y direction. If I rebuild my model at that, you can see that not only does the size of the block increase, but also the number of patterns, or the number of instances of that pattern in the X direction, goes up to 4. The number of instances in the Y direction goes up to 6 here. Now let's say if I was to reduce that down to 1 in the X direction and 1 in the Y direction, which is the smallest this block can get, of course. I'll reduce the Z direction as well to 1 while I'm at it. If I rebuild that now, you'll see that the last remaining stud would be that original one in the bottom left hand corner, which is corresponding to our where our origin for the part is, down in this bottom left hand corner here. Okay, so I'll increase that to something more like we'll go back to the 2 in the X direction and the 4 in the Y direction. I'm going to leave the Z at 1 for the moment and rebuild at that. Okay, so that's the top feature, the external stud on the top of the block completed, and the pattern feature. So I'm going to move on now to look at the internal stud on the bottom of the brick. Okay, so as I said before, this origin is here. Currently it's in the bottom left hand corner here. If you reduce the size of the part down to the smallest it can be, which is 1 by 1, this will be the this one here will be the last remaining stud. So when I'm creating the internal stud feature, I want to create this one here. The smallest block that will contain an internal stud would be a 2 by 2, so that's the smallest block there. So it's here, the internal stud closest to the origin is the one I'm going to model again, for the same reason I just outlined for the external stud. So I'm going to look directly up at the bottom view here. So hit the space bar and I can look up at the bottom of the part that way. Now my origin, if I highlight it here, my origin is in the top left hand corner here. So what was the bottom left hand corner, when you rotate it and you look up at it from the bottom, that becomes the top left here. Okay, so I'm going to create my internal stud on this location here. So I'm going to change my display style here to hidden lines visible. So we're looking up at the bottom of the part. We're looking at the bottom of these studs here. I want to model the internal stud then so that it's tangent to these external studs. So I'm going to create a circle. Actually, I'll create a sketch on that bottom surface there. So create a new sketch on that bottom surface here. You can see my origin is up in the top left, as we said. I'm going to create a circle roughly here somewhere. Actually, a pair of concentric circles. And rather than dimensioning that circle, what I'm going to do is to highlight the outer circle and then control click on the circumference of the external stud. Now that should pop up with a little tool here for your sketch relations. Alternatively, you can get those on the left hand side. You'll see the way that little tooltip disappeared. What I can do is just tap the control key on my keyboard and that reappears here. So I'm going to make those, add a tangent relation between these two circles. Okay, I'll do the same again. If I highlight that circle, control and click on the other circle, I can make a tangent relation between those two and repeat the process again. Select this circle, control and click on this circle down here and add a tangent relation. Okay, so that's the outer of the two circles is fully defined now. All of the circle really needs is 3 points in space to fully define it. For the inner circle, because it's concentric with the outer circle, the location of the circle is fixed, but the size of it is not fixed. So we can give that a dimension. So right mouse button and slide up to get the dimension tool. rather than giving it a diameter, what I'm going to do is dimension. So click on the inner circle, click on the outer circle, and that gives me the distance between those two. So I'm going to set the distance between those two circles to be 0.75 millimeters. That'll give me the wall thickness of that internal stud. And I'll just check now, but that sketch is fully defined. So I'm going to accept the changes to that sketch. So now with this sketch 4, that sketch is located, if I change my display style back, that sketch is located on the inner surface here of the shell feature that we created earlier. So I'm going to take that sketch, sketch 4, and create an extrusion feature from it. And you'll see that extruded out there. Now, rather than extruding that by a specified depth, I mean, I could calculate the depth there, but what I want is, regardless of the height of the block, whether we're looking at one Lego Z unit or 3.2 millimeters, or whether we're looking at a full block, which would be 3 Lego units or 9.6 millimeters, I always want this extrusion feature to be level with the bottom surface of the block. So rather than giving this a depth here, I'm going to change that from blind to up to surface. Okay, so it's going to start from the sketch plane. It's going to continue extruding until it comes up level with this surface here, the bottom of the block. Okay, so it's going to go up until it's level with face 1. And I'll OK that. Okay, so that's my internal stud. Now, as I said, if I come along later on and I change the height of the block, so I go back in here to manage equations and change this back to 3 Lego units or 9.6 millimeters. You see the height of the block has changed and the height of that internal stud has also changed to match. Okay, so that's the modeling of that feature complete. I'm going to do a similar process before now to create a linear pattern of that feature. Before I do though, I'm going to change my variables here once again. I'm just going to make this slightly bigger. I'll go up to say 4 by 6 by 3. Alright, just to illustrate the point here. So if I look down at the top surface of this thing again and change my display style. So this is the initial feature that I've modeled here. It's the one closest to the bottom left hand corner, or the origin. When I'm creating the pattern for this, I'm going to again pattern it in my X direction over this way, and I'm going to pattern it in my Y direction up this way. I want to create this such that in this case here, let's say there's four Lego units or 4 studs on the top. I'll need 1, 2, 3 studs on the inside. And the number of internal studs is always going to be 1 less than the number of outer studs. So if you've got 6 Lego units across the top, you're going to need 5 studs on the inside. Similarly then in the Y direction as well. Okay, so if I change my display style back to normal and I can just look at it from this way, say from the underneath. Okay, so I want to create a pattern of that feature there, the Boss Extrude 4. So I highlight it here in my feature tree, go back to the features tab and create a linear pattern again. So for direction 1 here, I'm going to again pick something, some edge running in the X direction. The spacing will be the same. The spacing is 8 millimeters. The number of instances here in this case, again, rather than picking a number, I'm going to use an equation here. I'm going to let that equal to my global variable x minus 1. So if I have 4 external studs, I'll wind up with 3 internal. You'll see then that calculates out a value here, x minus 1, or if I click on that, it should display the numeric value there, 3. So x minus 1, where x is 4, the number of instances will be 3. Okay, and spacing 8 millimeters is correct. So that's that. I'll do the same thing in the y direction then. So I'll pick some edge for direction 2, going down this way. The spacing again is 8 millimeters, and the number of instances here, we'll let that equal to our global variable y minus 1. Now, bear with me a second now. So try that again. Equals y minus 1. Okay. Equals y minus 1, and if I check the box there, that should calculate out to y minus 1 is 3. Or y is 4. Okay. This is the feature that it's going to extrude, and or pattern rather, and that should be fine. Okay, so that is the completed geometry for the part. Just check that everything is working. I'm going to change my variables once more. I'll say go larger here. I'll go up to 6 by 8 and rebuild it. Just check that everything is working. Okay, yeah, so 6 by 8, that's working. I'll also check it by going smaller. So if I go to say 2 by 2, 2 by 2 by 1, let's say, and rebuild that. So that's working fine at that. Now it is giving me an error here, no copies specified for pattern. So what's happening there is that the equation where we said the number of instances here is the external studs minus 1, so you're getting one instance, which means it doesn't actually create any copies. It just has the original feature and no copies created, but that's fine. Okay, so I'll go back again to our original, which was 2 by 4 by 3, and rebuild that. Okay. So that's as I said, that's the geometry completed for that part. A few other things we could do, we could assign a material for this. At the moment it doesn't have any material property specified. So if you come here to material, right click and go edit material, and we'll give that a material. If you come down to plastics, ABS, you'll see here that has some material properties for ABS. Now these are not particularly relevant to what we're doing at the moment, but something like, for example, the density here, that would allow us to evaluate the model and maybe see what the overall mass of the part. If we know the volume and we know the density, you could work out the mass. We can also change the appearance of it just to just give it some color, for example. So I come to the gloss here and I'll make this blue or green. Whatever. Okay, so we'll make that blue there. As I said, we've given it a material property. We've given it the material properties of ABS, so that would include strength and Young's modulus and density. We could look in the Evaluate tab, we could look at this here, you could figure out what are the properties, such as the mass properties. As I said, the software knows what the density is from the it knows what the volume is from the geometry. if you combine that volume with the density, it'll work out a mass here of 2.48 grams for the overall block. Okay. Okay, so that's the modeling process complete for the Lego block. Thanks for watching.